In the previous video, we've modeled an existing roundabout and assessed it as per current scenario using the 2019 demand. In this video, we'll look at assessing the same roundabout in future scenarios. Let's say we want to look at how this intersection will perform in about 40 years' time in 2062. With the same layout, we'll need to input the 2062 traffic volume. For simplicity, let's assume the combined background and development traffic growth is 3% per annum. Our first step will be to generate a turn diagram with the existing traffic volume as shown. It is likely that this intersection will fail in the future as the volume has increased. We will then have to do some option testing. You could just write L, T and R for left, through and right, but I think it's just much clearer with arrows, so I'm going to use these symbols instead. Majority of the time, we don't actually model the U-turn, but to make it exactly the same as what's on the left, I'll include the U-turn to make it simpler. Just a bit more formatting and tweaking around. Next step is to simply enter the traffic data from the left. Now, let's move on to the future traffic volume. Let's first write down our assumption and copy the turn diagram template from the existing case above. We will use the simple compound growth formula to calculate the 2062 volume. Fixing a few cell reference so we can just copy and paste the formula to the remaining cells. The good thing about referencing these cells rather than typing in the numbers is that you can easily get a new set of volume if your assumptions change. Notice that a few U-turns have stayed as 0 because there was no U-turn in the base year to begin with. So let's put in an extra assumption of minimum 10 vehicle for each turn. We can do this by tweaking the formula as shown. Again, keeping the 10 as a live cell, so if we ever change this number, say we want a minimum turn volume of 20, we don't have to change any of the formula except this one cell. Now let's move on to SIDRA. Right-click to clone the base site and create a future do-nothing scenario, which literally meant we're not doing anything to the intersection, just want to see how it performs with the new demand. After you've done that, enter the 2062 volume we just did in Excel into this site. And then hit process. Looking at the movement summary, we can see that the north approach has failed. There's also almost 2 km of queuing at this approach. The overall DOS and LOS of the site generally adopts the result from the worst turn. Now let's get into the option testing. First, clone the do nothing scenario. This way you don't need to enter the volume again, and you can just focus your effort on testing the intersection upgrades. I'm just going to add a slip lane for the left turners at the north approach, so they don't have to be stuck behind the through and the right turners. Now notice that the north approach no longer has LSF. However, the east approach, which was previously okay, is now failing. we effectively fix the north at the expense of the east. This makes sense because when we think about the operation of a roundabout, the east approach gives way to the north. By making the north flows better, the east approach will now find it harder to find gaps to enter the roundabout. This is a very simplified demonstration of the dynamic nature of traffic and how fixing something can break something else elsewhere. Now let's try to fix the east approach by adding a slip lane. As you can see, with 2 slip lanes, we have got rid of all the LOSF, which meant all approaches now have acceptable delays. However, the DOS is still failing. In some cases, client may accept this as a workable solution based on other factors such as cost, so I'll just keep this as our first option for now. For our second option, I'd like to test a 2-lane roundabout. There isn't really an off-the-shelf solution that is going to work all the time for every intersection you encounter. It's really based on your experience and guts to know what might work and then test them. Generally for roundabouts, you can just add slip lanes and circulating lanes. Things get a bit more complicated when you get to signalized intersections. For this roundabout, I will assume an additional 4-meter wide circulating lane and short lanes as local intersection treatments, meaning there will only be 2 lanes at the intersection, but not all the way through. As we can see, we've bring the DOS down to 0.7-ish and the delays are very good. At this point, you might want to optimize this further. Maybe not all approaches need 2 circulating lanes to get the DOS closer to 0.9 but not over. I've included a sample here. This will be beneficial from only the cost and construction perspective. But for demonstration purposes, we'll just leave it at that to keep the video shorter. Let's say now option 2 is the preferred option. We can do a flow scale analysis to see when this intersection is going to fail in the future. So let's clone option 2 and select flow scale analysis. Since this intersection is already at 0.7, I think it will not survive longer than 150%, so I'll set that as the upper limit. The graph under the side display will be the useful thing to look at here. Eyeballing at around the target DOS of 0.85, we are at about 110%. That is, if the volume increased by more than 10% after 2062, this intersection will be at capacity or fail. The last thing we're going to do here is to output the site layout and movement summary. Head to Tools to define a new report template, then select the attributes you want to report on. Site layout and movement summary in this case. Page break will put this attribute on the next page so it's neater. The next step is to select all the sites you want to report on, drop down on the site and select only the reporting template we just created and report on all movement classes. You can see a report of all the sites we selected has been generated. With this being the active tab, go to File and output the PDF. You can then send this along with your analysis and recommendation to your boss or your client. They will be able to see your work without having SIDRA installed. And this concludes the SIDRA tutorial series I had planned. If you make it to the end of this video, thank you for watching, and I hope you have found this helpful. Bye for now.